Welcome to 1D kinematics, speed and velocity. In the last video, we kind of introduced these concepts, and now we're going to go into them in more depth, including their equations. So we're going to start off with speed. So you can see here that we have speed, and it's denoted with a V, but there's no hat on top of it, because a hat would denote that it would be a vector, and speed is a scalar. So speed is how quickly an object is moving with no concern about its direction. Remember, a scalar is something that has magnitude but no direction. So speed is a scalar, and it has no direction. Average speed is found by dividing the total distance by the total time. Calculate speed when no direction is given. So here's our equation for average speed. So see this. This is V, and the AV stands for average. So the average speed. And here we have this D denotes the total distance. Usually we use SI units, and the SI units for speed or for distance would be meters, but you could also use kilometers. And then time, you could use seconds or hours. So here we have our total distance over our total time, and that's for average speed. Now there's instantaneous speed and there's average speed. So if you're at a stoplight and you're obviously stopped because you're at a stoplight, and then the light turns green and you accelerate, and let's say you started at 10 meters per second and you accelerated to 20 meters per second. Your instantaneous speeds would have been 0 at the start and 20 at the end, and probably in between it kept increasing little by little until it got up to 20. If you took the average speed over this time, it would probably be approximate, depending on the rate of acceleration and if it was consistent or whatnot, but it would probably be approximately 10 meters per second. So average is, we need to be aware of the terms average and instantaneous when we're referring to speed. This equation here, when we're talking about the total distance over the total time, is calculating the average speed. So you can put that into your equation page. Velocity is the rate of position. Velocity is found by dividing the displacement by the elapsed time for that displacement to occur. Calculate velocity when direction matters. So this is very similar to our speed equation. Here we have it's still a V, but now we have our little vector on top because velocity is a vector. Here's average. And instead of total distance, we have our total displacement, okay? Divided by our total time. So here's an example. Runner Usain Bolt ran the 100-meter dash in 9.58 seconds. What was his average speed? So here's our equation right here. And so we just plug things in. If we look at this equation as we read it, anytime you see a number, you're going to define what that is. So 100 meters. Is that a displacement, a position, or a distance? This would be a distance, right? So that's our distance. And then here we have 9.58, and that obviously is our total time. So what was his average speed? We plug those in. We have 100 meters over 9.58 seconds. And if you use your calculator, you would calculate 10.438 meters per second. Usain Bolt's average speed was 10.4 meters per second. Here's an example using velocity. A plane travels 376 kilometers southeast in 5.2 hours. So if here's our starting point, it's going, if this is like north, south, east, west, the plane is traveling southeast, and it's traveled a total of, relative to the starting point, 376 kilometers in a time of 5.2 seconds. What was the plane's average velocity? So the displacement, the ending position relative to the beginning position, is 376 kilometers southeast, right? 376 kilometers southeast. And our total time is excuse me, 5.2 hours. I wrote that incorrectly. This should be 2 hours. So here, this is our total time. So if we use our calculator, we get 72.31 kilometers per hour southeast. So the plane's average velocity was approximately 72 kilometers per hour southeast. And that is the end of speed.